Basic force problems. Using force diagrams and force tables. Please make sure you are following along in your packet. Pause the video as necessary to make sure you have all the information. A 0.16 kilogram hockey puck glides across ice at a constant velocity. Constant velocity means balanced forces. Draw a system schema and force diagram for the puck. Our system represents the puck, and it interacts with the earth through a force of gravity. The ice interacts with our puck through a normal force. Ice is very slippery, so it has little to no friction. Let this dot represent the puck. We know the force of gravity pulls the puck downwards, so there will be a downwards force of gravity by the earth on the puck. There will also be an upwards normal force by the ice on the puck. The velocity is constant, which means the forces are balanced. Balanced forces means that the net force is 0. So both of these vectors should be the same size. The net force is the total force, or the sum of all the forces. So the net force would be F1 plus F2 plus F3 and so on. For this problem, the net force is equal to the force of gravity plus the normal force. We know the forces are balanced, which means that the total force in each x and y direction is 0 newtons. That's what balanced forces tell us. The x direction is horizontal, with right being positive and left being negative. The y component is the y direction, which is up and down, where up is positive and down is negative. Now we can write our forces. We have a force of gravity, and the force of gravity acts downwards, so there's 0x component. We know that the force of gravity is equal to m times g, where g is the gravitational field strength, and g can be written as 9.8 newtons per kilogram, which we can round to 10 newtons per kilogram. Force of gravity is equal to 0.16 times 10, which is negative 1.6 newtons. The negative sign tells us that it's downwards. Down means negative. Now we have the force normal. It acts in the upwards direction, so the x component would be 0 newtons. In order to figure out the normal force, we can write our net force equation. We can plug in the 0 for the net force and negative 1.6 for the force of gravity, which tells us that the normal force is 1.6 newtons upwards. So we said they should be the same size, which makes sense. 1.6 newtons up and negative 1.6 newtons down. A horse is pulling a 55 kilogram wagon. The wagon travels at 12 meters per second. The horse pulls with 100 newtons. Try this one on your own. Remember to draw a system schema, your force diagram, and fill out your force table. So our system is the cart. The cart interacts with the earth through a force of gravity. The cart also interacts with the horse with an applied force. The cart interacts with the ground through a normal force. And because the wheels are rolling, the cart interacts with the axle through a force of friction. The horse pulls with 100 newtons to the right, so we know the rightward force is an applied force by the horse on the cart. The earth pulls the horse down, the force of gravity by the earth on the cart. The force normal by the ground on the cart is upwards, and the force of friction resists its motion to the right, so it'll be to the left, force of friction by the axle on the cart. Because it moves at a constant velocity to the right at 12 meters per second, the net force is 0 and the forces are balanced. Remember that the x direction is horizontal, with right representing the positive direction and left being the negative. The y direction is vertical, with up being positive and down being negative. Let's first fill out the forces we know. We know there's a force of gravity. We know there's a normal force, an applied force, and a force of friction. The forces are balanced, which means the net force is 0. Because we have two directions, we have to include both the horizontal net force and the vertical net force. So the net force in the y direction is 0 newtons, and the net force in the x direction is 0 newtons. The force of gravity has no horizontal component because it acts down. The normal force also has no horizontal component because it acts up. The applied force is to the right, so it has no vertical y component, and the force of friction is to the left, so it has no vertical y component. We are told that the applied force is 100 newtons to the right, so that means it's the positive direction. In order to figure out the force of friction, we can use the net force in the x direction equation. And the net force in the x direction is the applied force plus the force of friction. So 0 equals 100 newtons plus the force of friction, so the force of friction must be 100 newtons to the left, or negative 100 newtons. We can calculate the force of gravity using our force of gravity equation. So our force of gravity would be negative 550 newtons, which means downwards. The net force in the y direction is the force of gravity plus the normal force. The net force is 0, the force of gravity is negative 550 newtons, and the normal force would then have to be 550 newtons positive or up.